Hey everyone. Today we're going to be talking about equations of trig graphs. So we've spent a lot of time graphing the graphs given the equation. Now we're going to go backwards. Basically, I'm going to give you the graph and you tell me the equation. In order to do that, there's a couple of things that we can state specifically: amplitude, period, frequency, principal axis, just by looking at the graph. And using those four pieces of information, we can come up with the equation for the graph. So let's start on the first one. I'd like you to try and fill out the first four pieces of information, and then we'll come together and figure out the equation. So when you fill out the information, you find out that the amplitude is 4, that it takes 180 degrees for one complete sine function to make its way around in a full cycle. You notice that there are two cycles in 360 degrees. That's the frequency. So from here to 180 and then 180 to 360. And the principal axis is 0. Now, some people would say, Mr. Mtula, how do you know that the equation should be a sine graph or a cos graph? Well, my biggest hint is the following. If the function starts at the principal axis, like it does here, then it's a sine function. If it doesn't start at the principal axis, then it's probably a wise idea to use the cosine function. So using this information here, I can get that y is equal to 4 sine 2x. The 4 being the amplitude, the 2 being the frequency, so 360 divided by 2 gives me the 180. And because the principal axis hasn't moved up or down at all, then I don't need to add that information on at the end. Okay, so let's look at this next example. Sorry. State the amplitude, the period, the frequency, and the principal axis. Well, right away you notice that this isn't around the x-axis. So you have to figure out where the principal axis is, and it's halfway between the maximum and the minimum. So here the principal axis is at y equals 4. Given that, I notice that the curve doesn't start at the principal axis, so I'm going to use a cos function. I notice that the amplitude is 1, however, it goes down instead of up, so it's been reflected. And the period is 360. So putting all that information together, I get the following equation. Notice that the equation has a negative sign in front of the cos because it starts negative. And notice that there's a plus 4 at the end. This plus 4 means that the principal axis and the entire function moved up 4 units. Alright, well, try the next example. Fill out the information and try the equation. We'll see how it goes for you. This one's a little trickier. Well, you'll notice that the amplitude is 1. The period here, it fits exactly 1, 2 and a half. 2.5 in 60 degrees. So that means it fits one cycle in 24 degrees. That means that in 360 degrees, I'll get 15 cycles. The principal axis here is 0. So, and again, because the curve doesn't start at the principal axis, I'm going to use a cos curve. So this is y is equal to cos 15x. Alright, we'll give this example a try. Again, state the four things and try to figure out the equation. Come back and check your work. For this example, it's really handy to start with the principal axis, right here. If I label that on my diagram, I can see that the amplitude is 3. I can see that the period, or the whole cycle, takes 1440 degrees. That means in 360 degrees, I only have a quarter of a cycle. Because my graph starts at the principal axis, I'm going to use a sine function. So here I get y is equal to 3 sine a quarter x. You can put that in brackets if you want. And then plus 1. So a little bit tricky, but using the information that I have here, it makes making or writing out the equation from a graph really, really simple. Okay. Give the next two examples a try. I'm going to encourage you to pause the video, try them out, come back, and check what I have to say. Okay, well, this one again, it's really easy if we start with the principal axis. So if I label that, it's at y equals 2. From that, I figure out that my amplitude is 2. I also figure out that it takes 120 degrees for one cycle to happen. That means there are 3 cycles, or the frequency is equal to 3 here. And I also notice that because my function starts at the principal axis, I'm going to use a sine curve. So the equation is y is equal to 2 sine 3x plus 2. Last example. So in this final example, I again start with my principal axis, which is here at y equals 0. When I do that, I notice that from 0 to 360, I only have half a curve. That means the period is 720 degrees. I also notice that the amplitude is 2, but that it starts in the negative direction. So that's why I've written reflected right here. So my curve, or my equation for my curve, is y is equal to negative 2 cos. Again, the reason I use cos is that it did not start at the principal axis. So y is equal to negative 2 cos a half x. Take an opportunity to try the homework. It's set up very similarly to the lesson, so that way you can practice writing down the key information and getting the equation from that key information. Thanks, everyone.